Okay, moving on to example 6, we got log base 2 of 9x cubed minus 16x, and again it says find the domain. So again, all I care about with domain for logarithms, once I see it's a logarithmic problem, is what is the argument. That's what matters to me. The rule very clearly states that the argument itself, which is 9x cubed minus 16x, must be greater than 0. And what we're looking at is a polynomial inequality. Now we dealt with in chapter 1 quadratic inequalities. It's the same family of problems. What I want to do is I want to get this in factored form. Okay, so x is a common factor. And then 9x squared minus 16 is the difference of squares. So 3x plus 4, 3x minus 4. Main idea is factor completely to the extent you can. Now do linear terms if possible. If you can't factor to linear terms, then your quadratic thing is not factorable. Maybe do a quadratic formula to find out what the factors would be as irrational numbers. Or if it's imaginary, it doesn't matter. Okay, then those zeros count there. Okay, all we care about is real zeros in this situation. So I know that at x equals 0, x equals negative 4/3, and x equals positive 4/3, based on these factors, setting each one equal to 0 and solving using basic algebra. 0, obviously, move the number, change the sign, divide by 3. Move the number, change the sign, divide by 3, right? So those are my zeros. Those are the places signs can change for that specific function. All right? We can see very clearly by the even and odd powers of x minus c theorem that we saw in last chapter, odd powers never once, these are all crossing ones, right? So I know that from negative infinity all the way to 0, some sign is going to occur. And then the graph's going to cross the x-axis, either up or down, I don't know which way yet. Then it's going to go from, oh sorry, not to 0, hang on. Got to do them in numerical order. First number numerically is negative 4/3. Sorry. Then it's going to cross the axis at negative 4/3, either up or down, I don't know. And then at negative 4/3, until 0, it's going to be another sign until it crosses the x-axis again. From 0 to 4/3, there'll be another sign until it crosses the x-axis again. And finally, from 4/3 to infinity, it's going to be some sign. If I wanted to go even further than this, using all the tricks of the trade that I learned back in the other chapters, this first term is a positive odd-powered term, which tells me it's down, left, up, right. So it starts negative, switches to positive, switches to negative, switches to positive. I can figure that out right off the bat real easily. So here's this, negative 4/3, 0, 4/3, right? So it's down, left, up, right. So I know it does that. So I can very clearly, just based on those two little facts, know that it's negative, positive, negative, positive. If I wanted to be 100% sure though, if I pick x equals negative 2, that's between those numbers. X equals negative 1, which is between those numbers. X equals positive 1 between those numbers. And x equals positive 2 between those numbers. And all I have to do is figure out the product here, right? So this x would be negative. That'd be negative 6 plus 4 is negative 2. Negative 6 minus 4 is negative 10. Oop, negative 10 doesn't matter, the negative matters. 3 negatives make a negative, right? Which verifies my assertion, right? Yep. All right. If I go then negative 1, x of course is negative 1. Negative 3 plus 4 is positive 1. Negative 3 minus 4 is negative 7. 2 negatives times a positive makes a positive. For 1, I'm going to get positive. 3 plus 4 is positive 7. 3 minus 4 is negative 1. 1 negative makes a negative. And for 2, I'm going to get positive, positive, positive. Because 2, 10, and 2, right? So all positive. Okay, what we want is greater than 0, right? So the two that we care about would be this one and this one. So our domain for this one would be equal negative 4/3, comma 0, union with 4/3, comma infinity. And again, write the answer in integral notation. That's the easiest way to write that. The set builder notation for this will be the domain equals the set of all x such that negative 4/3 is less than x is less than 0, comma, x is greater than 4/3. Got two facts here, so x is between negative 4/3 and 0, not inclusive, so no equals. And then this is everything greater than 4/3. But again, they asked for integral notation here. I'll accept either. I think integral notation is a little bit more efficient to write than set builder notation. You don't have to draw those braces either, which I don't have any problem with that side, but this side's kind of tough. So, you know, there's lots of bonuses for that. Just be careful though, brackets, parentheses are the question. Logarithms always have a greater than or a greater than symbol. There's no equals to, so you're going to get parentheses every time with these domains for logarithms. So be careful that you don't put brackets on your interval notation.